So the first thing I wanted to show you guys is what is multi-factor authentication and kind of what it looks like for your users. And it may be something you're familiar with, but let's just kind of show it to you here. And if you're not familiar with it, the example that I generally give is it's kind of like your debit card for your bank. A bank would never issue in a million years a debit card, or hopefully they wouldn't. A debit card that doesn't have a PIN number on it, you would need the physical debit card, and you also need the PIN number to get your money out. Multi-factor authentication is similar to that in that you don't want to give access to the corporate resources, until you have two forms of identification. One being the physical, the debit card in this example, and the other one being what which is the PIN number. So when we were looking originally at this login screen, this is where you would normally go. But let's take a look at what would happen when I tried to log in for the first time. Assuming I type my password right. It's always a good test. You could see here that I have the password right, but I have to approve an additional sign-in request if I want to get in. And right now my phone's dinging, which ultimately means that there is a prompt on there that I would need to get into if I wanted to get logged in. So even if the hacker, like Dave said, bought my password off the dark web, there is another gap there. Another one of the cool things about this is there is a deny option, like Dave was talking about on the prompt that I just got. If I hit deny at 3 in the morning when my phone wakes me up because someone's logging in as me, we have logic and automation in the platform that will automatically lock my account and force me to reset my password. And the only way I'm going to reset the password is if I can validate who I am through multi-factor. The other thing I wanted to show you just before we go on to the other areas of the demo is if Dave was mentioning passwordless sign-on. So let's just take a look at that real quick right here. So say I went back to that website again, office.com, and I went to sign in. So a new user gets, or the hacker gets in, or one of your users, they put in their email address. It says, what's your password? There's other ways to sign in here at the bottom. So there's all different options, all the methods that I've enrolled. But the passwordless version is approve a request on my Authenticator app. And you can see here that, it will ask me to go to my Authenticator app, hit the number 16 on the Authenticator app, and then presumably it would log me in here. Now, at AMP, we have an additional set of authentications where even though I just approved this sign-on, it's going to prevent me from getting there because I'm coming from a non-compliant device. So security is all about layering your solutions for security. So even if my password gets compromised, somehow there's a nation state attack and they can compromise multi-factor authentication, there's still another layer in here where you have to be coming from a compliant device. So that's kind of what multi-factor look like in a nutshell, and the different types that are available. The next thing I wanted to show you guys what kind of features you have when you enroll your device in Intune and with Defender ATP. So let's take a look at that portal. This is the Microsoft 365 Defender portal. And you can see here, we're actually looking at one of our AMP engineers' machines. And the engineer in question, if you know him, is Phil. So if you do have one of his tickets, give him a hard time about this, but not too difficult of a time ultimately. But this is a real example of a problem that we had with Phil's machine. You could see in here we have alerts that come up for his machine, a timeline of all events for his machine, which I will go back to, a list of security recommendations, all the software that's installed on the machine, vulnerabilities that are on the machine, and any missing patches. I also have the ability to restrict certain apps from running AV scans, and isolating the device immediately from the network just by clicking this button. I know Phil's working, so I won't do that right now. But let's go into the Discovered Vulnerabilities tab. And you can see it automatically lists several vulnerabilities on Phil's machine that we need to remediate. And these are vulnerabilities that aren't even in just the Microsoft ecosystem. So for example, if we click into this critical vulnerability at the top, you can see here that it's picking up an outdated version of 7-zip on his machine. I asked Phil to leave this on his machine as an example. But you can see that it actually detects not just Microsoft software, but all software on the machine, and kind of gives you a full view of what's on the machine and what's vulnerable. It's not just looking at. The next thing in this platform that I wanted to show you is the timeline. So if we click into the timeline, it's going to take a few seconds to load, so just be patient here. But what this is at a high level is pretty much every click and every view of what every service did on your machine. So for the last, just scrolling down here from what you're seeing, me scrolling here, this has been about halfway down this page. That's only gone back 20 minutes. So this is logging every connection that Phil's web browser makes, every token that his team's client receives or doesn't receive, everything that his Outlook connects to. And why this is useful, and we'll kind of see it later in the demo here, but it allows you to really have a good understanding of what happens when a breach occurs or when a breach potentially occurs. And what I mean by that is, previously in IT, and I've been doing this for a little while, but in the early days of doing this, you'd get a user who clicked on an email, and you would say, oh, what did that user do? Did they actually click on it? Did it get forwarded? What happened on the machine after they clicked on it? You go to the event logs, and the event logs only go back 3 hours because no one configured retention. Or the user was off the network and they couldn't get back to your security appliance on site, so it never got aggregated up, and that retention was lost. All of these logs are being sent to Microsoft without a VPN, without any interaction with any network. Phil's working out of his home office today, and all of these logs are getting there no matter where he's working. So he could be at a Starbucks when a security event happens. He could be on our corporate network when a security event happens, and we would know about it. And that's really important, because if an issue does happen off network, you want to make sure that device doesn't come back on your network. So having this level of logging and being able to click into any of these things and flag them as important or not important really helps in the incident response side of things. The next thing I want to look at was alerts. So there is an alert on Phil's machine that I haven't dismissed yet for the purposes of kind of showing you guys. So let's let this load here, and we'll click into the alert and see what kind of information is available to us. So you can see here there was an Okami malware on Phil's machine, and we can click into it to get a lot more detail about exactly what happened. So it says here on 6/23/2021, Phil's Explorer process at 1:50 p.m. listed in his file browser a keygen for vCenter. And if you're not familiar with what a keygen is, it's, if you pirate software, if you download pirated software, you may not have a key for that software that you're pirating. So you would run a keygen utility on your computer to get a key generated for you. Sounds really great, but generally speaking, if you're running these things, hackers know that the person who's going to download a vCenter keygen is most likely going to be an administrator. And that's where they're going to put their malware on. So the Okami malware isn't a serious infection. And this is probably ultimately a false positive, and I can show you how I got to that. But our solution did find it and fix it immediately. So let's take a look at this. We could see in the bottom right-hand corner here, down here, that it was automatically prevented. The alert was generated on June 24th, 2021 at 4 p.m. The times are a little bit off just because of UTC to Eastern Time translation. But the main point to really get here is we're in September. I'm able to see this alert from June in September with this level of granularity. And I could see everything that happened. So let's looking at this, we could say, okay, at 1:50 p.m., the first time the Explorer process listed this file, it was scanned, it detected something, and it prevented it. And what that means is it deleted the file. The interesting thing is Phil's a tinkerer. He has his own home network. He has his own home lab. He has racks of servers in his basement. So it actually detected this file on his NAS in his basement that he had a connection open to grab an ISO off. In that 1 or 2 minutes that he opened up a browser to this NAS at his house, it scanned the entirety of his NAS, found this file, and cleaned it off. Looking at it, you can see down here that afterwards it found the malware. The next thing it said that that Edge launched, And then down here, this would be really suspicious. What this is saying is that his machine tried to connect to another machine in the office, and then a few minutes later, tried to connect to another machine in his office. Now, because I know Phil has a lab and I've already verified with this, he was working on this at 8 o'clock at night and spinning up VMs to build in his lab. And these were legitimate. But if this was Debbie from accounting, who has no idea what remote desktop is, and we saw 2 or 3 connections coming from a machine to other machines in your network, it would be a completely different story. And having this knowledge or having this detail allows me to make educated decisions to know if someone's compromised. Do I have to wipe the machine? Was it a malicious event, or was this just a gray kind of infection? And beyond that, I can continue to scroll down just to kind of look in the next couple of days. Did anything happen that was strange? And really, other than a few connections here or there and Phil's desktop software that he runs, there really isn't anything that really concerns me. So, this is one of those ones that we could go in here and classify as a true alert. And then Microsoft would use that to improve their analytics. And the next time this happens, it would trigger off more immediately. And if you wanted to, you can scroll down here. It does give you a lot of information about what the alert is, what the recommended actions are. As part of A&P service, we manage all this for you. But this is the kind of granularity and the detail that we get when we manage these things as they're happening in your environment. And again, this is all cloud-based, so there is no need to have a local network or anything like that. The next thing I wanted to show you guys is Azure Sentinel. And what I reference Azure Sentinel as is kind of, there's a lot of different, watchtowers in Microsoft 365 and in your environment. So that could be your Meraki portal. That could be your backup appliance. That's not a Microsoft appliance, let's say. It could be your switches, your sysllogs, all the event logs from your workstations, all of these different things. They're all independent systems and they all put their hand up independently. What Sentinel is a unified aggregation for all of those logs in a single pane of glass that allows us to implement automation. So if an alert comes up in Defender that Phil clicked on a spoof email, I can have Sentinel go to every user's mailbox in our organization and proactively delete that message. On the flip side, if Meraki detects some kind of vulnerable device or some kind of vulnerable condition or indication of compromise, I could actually use Sentinel to go to that user's machine and lock them out. And that's just one piece of Sentinel. And I'm going to show you a little bit more about it. But the main thing of this is that it is not really anything on its own, but it is a central pane of management that all of your individual watchtowers kind of report back into. So let's look at an event. This is one that I generated for the purpose of this demo, but you can see there's other ones in here, and some of them are kind of scary, and some of them aren't. Files containing PHI. I've looked into these. These are the people who should be sharing them, so they aren't really super concerning to me. But if I did see, for example, one of our engineers, and this has happened, putting their 401k or W-2 in the wrong spot, I can use that as a training exercise. Sentinel will still pick that up. We'll still let an administrator know or a compliance officer know. And then I can use that information to, like Dave said, identify problem users and train them. So it's not just for indications of compromise or breach. It's also for things like your data loss prevention platform firing off or your compliance or regulation requirements firing off. It aggregates everything in here. And that's what kind of makes it a full featured security product. So getting back to this example, this is what would normally be a terrifying thing if I didn't really know what it was, but it says that there was an administrative activity from a non-corporate IP address involving one user. And what that means is that it's noticing an admin doing activity outside of our network. I can click into this alert here. I can see that it was my M. McCarthy admin account. I can see right here from this one click what IP was involved and that it was the Cloud App for Security portal. Knowing what I know, if I was, in incident response or on the NOC team that monitors this for our clients, I would say, okay, I know that this is Matt McCarthy's test IP, so I don't need to worry about it. And we can create automation around these. So if this alert comes in with this IP address, it would be excluded but logged from being alerted. But let's go into the assumption that we need more detail on this, and we kind of figure out what this is. So to do that, we're going to open up the alert like we did, and then we're going to go down here to view full details, and we're going to click on that. So when that loads, you see it's kind of an explosion of that little pane of glass that we were looking at previously. And we have up top here the ability to look at the timeline. So if there was multiple instances of this alert, it would aggregate them all together so I can make a decision based off of all the alerts. In this example, this is really just the one thing that I purposely fired off. So there really isn't going to be more of them. But if there was, you could use that in your incident response, or AMP would use that in their incident response if we were managing this for you, to make a really good educated decision. Alerts, again, is similar alerts. It will list all the alerts here, kind of not in a timeline format, but it shows you a lot of detail for it, and any playbooks or automation associated with those alerts. Bookmarks, if you wanted, if one of the guys on my NOC team, or if I wanted to attach a bookmark or a KB to every time this alert fires off, I could do that here. Entities is just kind of, like I said, an explosion of this entities panel down here, where it shows you the everyone who's involved, and you can click into them to get more detail. And then the comments, if people wanted to have a chat, if we were communicating with a client, comments are really important for your auditors. They like to see the full life cycle of what happened with that vulnerability and what notes were made or not made. So rather than being in a disconnected system, your auditor could get in here and see all the comments and why, or the who, what, when, where, and why on how something was resolved. But this still doesn't really give me, let's say I kind of recognize the IP, but I'm not totally clear because it's assumed this isn't mine. And I want to just get a little bit more information before I rule this off as a false positive. So what I'm going to do down here is click on investigate. And that gives you a really rich spider chart and the ability to kind of expand each one of these entities that I was referencing earlier to get a little bit more detail. So you can see here that everything's connected with a red line, and red means critical. It's generally a bad thing if you see red, and that applies here. But let's look at the Matt McCarthy admin account. And this little pop-up here gives me the ability to expand any related alerts that this account had. So let's look at, so was there any other alerts here that occurred on the Matt McCarthy admin account? So it says here that there was an unusual addition of credentials, that the Matt McCarthy admin account did some weird SharePoint operations. There were some rare and potentially unusual connections, and that I configured new access credentials into the tenant. Now, if I was an incident response person, this would terrify me if this wasn't an example, but this would be, okay, this seems suspicious. Matt McCarthy did something that he doesn't normally do from an IP address. Did he do anything else that was suspicious? Okay, yeah, he added an unusual credential. And again, I can go ahead and I can click into this and see anything that's related to this alert and kind of get a full picture of exactly what happened with all that level of logging that goes back months and months and months that I referred to earlier, all in one single pane of glass. And I can see exactly what the person did. Or what they didn't do, because not every indication of compromise is a breach, and it's just as important to be able to rule out the false positives. I could see, the times the account has successfully logged on, the times that the account has failed logons. I could see what host the account logged into. If they made any connections from rare IPs, I can even see if they took a screenshot while they were logged in and what they took screenshots of, to look for data exfiltration. And there's all sorts of different things. But the important thing is I can also see that they didn't take a screenshot. Right here, that they said there was there's a 0 next to it. So I could say, it doesn't look like any data was exfiltrated. It doesn't look like they spread to any other IPs or that they created any services while they were logged in. But these other things are suspicious. Let me talk to Matt, and I talked to Matt, and he said that he did add these access credentials for a line of business that he was testing, and he was doing these things for SharePoints for a proof of concept for another client. So normally you kind of have to play the guessing game to know what happens, and the whole point of this is Sentinel will give you the ability to know exactly what's happening, and it also allows you to build automation around it. So all of your logs will be there forever. And they're stored in Azure for an indefinitely long time, based on your retention periods that we all set up and manage for you. And this is all stuff that we do for people as part of our secure cloud offering. And it really is a great tool that allows you to have a full idea of what's going on in your environment, and more importantly, maybe what's not going on in your environment. So that's Sentinel at a high level. I covered the MFA today, the Windows Defender security, which kind of integrates into Microsoft Endpoint Management, and the Defender ATP licensing. And then the last thing I showed you guys was Intune, was Sentinel. So covered a lot, but only covered a little of each topic. And if there's anything else you guys want or more clarification on, just reach out and I'd be more than happy to show you more or drill into any of these topics in more detail.